VMware Cloud Foundation 9 creates a single, unified abstraction layer over complex distributed infrastructure. While this simplifies management, an automated deployment failure can be difficult to diagnose when the top-level interface masks the architectural root cause. In this real-world case, an engineer attempted to create a new workload domain, only to have the entire orchestration process halt unexpectedly. The standard operational starting point is the Fleet Management Dashboard, which logs the failure under the Validate Workload Domain Deployment Specification task. The natural reactive response is to rely on this red failed status indicator to understand the outage. However, high-level dashboards are designed for orchestration, not deep-tier diagnostics. To find the answer, we have to move past the management layer. To find more context, we expand the specific failed task within the UI. The interface presents progress messages and error fields, but information is limited. Failed to validate domain spec is merely a symptom. It provides no actionable intelligence. We need to shift our focus to the reference token string located at the bottom. At this stage of the investigation, this reference token is the only operationally valuable data point on the screen. Because the UI is presenting a symptom rather than the cause, the engineer must use this token to bypass the noise and interrogate the underlying system. The traditional instinct during an outage is to SSH directly into the SDDC Manager appliance to hunt through thousands of lines of text logs. If we visualize a cascading system failure on a timeline, we can see the logic of the logs. This illustrates the golden rule of troubleshooting. The very first error in a sequence is the actual root cause. Everything that follows is a symptom. The error we saw in the dashboard sits at the very end of this chain, making it the least useful piece of evidence. While you could find the first error by running grep commands against domainmanager.log, that manual process is too slow for a live production outage. VCF 9 provides a structured API method to extract that critical first error instantly, removing the need to parse raw text. The SDDC Manager Developer Center serves as the primary interface for bypassing these UI abstractions. This is the built-in Swagger UI. It allows us to execute API calls directly within the SDDC Manager environment. Accessing the API natively is more efficient than configuring external tools like Postman while an incident is actively unfolding. To investigate the workflow failure, we use the getv1/tasks endpoint. We inject the reference token we copied from the dashboard into this query to isolate the specific task that failed. This turns the Developer Center into a diagnostic bridge, allowing SREs to pierce the management layer and see the raw data the UI hides. With the required parameters set, we execute the API call. The API response returns a page of task list. We immediately identify our target, creating workload domain, SA workload domain 01. Expanding that task reveals the primary error payload. We see the error code, public domain spec validation failed. The reference token here, 2OB90L, matches our UI perfectly, confirming we have the right event. But even here, the top-level message is still generic. The real root cause is buried deeper in the JSON. We need to look specifically at the nested errors array. By expanding the nested error block, the system finally reveals the truth. ESXi host already has vSAN enabled. This translates to a clear operational reality. The target ESXi host was improperly pre-configured with vSAN before the automation workflow began. This pre-existing configuration caused the automated domain validation to crash because it encountered an environment that didn't match the deployment spec. By interrogating the nested JSON, the engineer turned a vague dashboard error into a precise, actionable fix for the ESXi host. While this API interrogation is effective, it is still a reactive response to a failure that has already occurred. VCF 9 shifts this dynamic by centralizing telemetry to identify configuration issues, like that vSAN mismatch, before a deployment even starts. This is the VCF Health Dashboard. It provides a proactive view of the operational state of the entire stack. The interface consolidates live data, allowing you to navigate from the management domain down to individual vSAN clusters and hosts. Instead of hunting through JSON payloads under the pressure of an outage, these misconfigurations are flagged automatically here. Shifting the workflow toward continuous health monitoring reduces the time spent in high-pressure troubleshooting by surfacing these errors before they can block a deployment. This proactive data is gathered without overwhelming the environment with telemetry overhead, The diagnostic findings engine uses a primary node to pull component properties and logs directly from the data plane. A rule engine then evaluates these properties against a catalog of known signatures. This allows the system to preemptively check for things like NTP drifts or certificate expirations that frequently cause deployment failures. Effective management in VCF 9 relies on a two-part strategy. You must use the VCF operations engine to maintain a quiet fleet, while retaining the API skills necessary to pierce the abstraction the moment a complex system breaks.